we now start with derivatives. To start, to start with derivatives, we need to know the five basic derivatives. So the five standard derivatives we need to know first, only then we can proceed. Now, the five standard derivatives are as follows. We always write if y is a function, we always write its derivative as dy by dx. So this is the writing technique. If say y is equal to x square, we write the derivative as dy by dx, and then we replace the y by x square. This is the writing technique. So if y is a function, we write its derivative as dy by dx. Say suppose y is e raised to x, what do we do? We write the derivative as dy by dx, and this y is replaced by e raised to x. Now what do we do is we learn the five basic or five standard derivatives which we need. The first the standard derivative is y is equal to a k. That means if y is any number, say y is 2, 1, 0, 1, any number, then the derivative of y, which is nothing but d by dx, here we replace y by k, the answer is 0. The second standard derivative is suppose y is x raised to n. That means if I is x raised to a number, say x raised to 7, x raised to 101, like that. So then the answer is dy by dx, which is d by dx of x raised to n is nothing but n x raised to n minus 1. That means the number and x has one number less, x raised to n minus 1. The third is suppose y is e raised to x. Then dy by dx will be d by dx of e raised to x. The answer is e raised to x. And the fourth one is suppose d by the dx of suppose y is k raised to x. K raised to x means what? Something like 7 raised to x, 9 raised to x, like that. So that time dy by dx, which is given by d by dx of k raised to x, is nothing but k raised to x log k. So this is the fourth thing. Fifth last one is suppose y is log x, then dy by dx will become d by dx of log x, and the answer is 1 upon x. These are the five standard derivatives which one should know. Apart from these five standard derivatives, one should also know two basic techniques of derivatives. The first one is suppose I have something like this. Suppose my y is some number into, say, f of x. Say some number into f of x. Say something like y is 7 into e raised to x, or y is 9 into x raised to 7, something like that. So that time what we have to do is dy by dx will become d by dx of 5 f of x. We replace y by whatever is over here, and now we remove the number out and we focus on the x part. So the idea is suppose I want to if y is say 7 e raised to x, if I want to find dy by dx, then what I do is I just take d by dx of 7 e raised to x. I remove the 7 out and I just focus on derivative of e raised to x, and derivative of e raised to x is e raised to x. So suppose I find derivative of say 2x raised to 7. What do I do is I say dy by dx, I replace y by 2x raised to 7. I remove the number out and I find the derivative of only this x raised to 7 part, and the answer of derivative of x raised to 7 is 7 x raised to 7 minus 1, that is 2 into 7 into x raised to 6. This is one basic technique which one should know. The other basic technique is, suppose there are d by dx of, suppose our y is made up of two parts, say f of x plus g of x. Now when I want to find dy by dx, I will just replace y by f of x plus g of x, and in this case what I have to do is I have to share the derivative with f of x and share the derivative with g of x. So suppose if I want to find the derivative of x raised to 7 plus say e raised to x, there are two things, one here, one here. So what do I do is dy by dx, I keep d by dx as it is, I replace x raised to 7 plus e raised to x, and then what I do is what, I replace d by dx of x raised to 7, I share the derivative with both, d by dx of e raised to x, derivative of x raised to 7 using this basic technique over here will turn out to be 7 x raised to 6, and derivative of e raised to x is e raised to x using the basic technique mentioned over here. So these two techniques we need. Now we proceed with the problems. Our first problem is y is 5 x raised to 7 plus 7 x 5 by 3 plus 1 x square plus cube root of x plus square root of x. In this case, our first aim is to bring everything to the forms which we know. Now, the forms which we know are something like x raised to number. We have to bring all these terms which are here into the one of the standard form. Now, if you recollect, our standard forms were y is equal to k, y is equal to x raised to number, y is equal to e raised to x, y is equal to k raised to x, and y is equal to log x. These were standard forms. So our aim is to, in this problem, is to bring all these first terms into standard form. Standard forms are k, x raised to number, e raised to x, k raised to x, and log x. Our aim is to bring all these terms into standard forms. So we first bring it to standard form. Now this is already in standard form. Why x raised to 7 is already in standard form? Because x raised to 7 is this category. This also 7 x raised, yes, the 5 by 3 is also in standard form because it falls under this category. Yes, this number is attached, but this number is not creating any problem. Now this part is not in standard form, so we bring it to standard form by taking this x square on top, and we take it to on top by putting negative sign. Similarly, now, so what we do is we convert this 1 upon x square into standard form by taking this 2 on top, and when we take on top we have to put minus sign. Similarly, this cube root will be replaced by 1 upon 3, and this square root will be replaced by half. Cube root, any cube root will get replaced by 1 upon 3, any square root will get replaced by half. Now we find dy by dx, because now all of these things are in standard form, all are in x raised to number form, so we find d by dx of 5 x raised to 7 plus 7 x 5 cube plus x raised to minus 2 plus x raised to 1 upon 3 plus x raised to half. Now since there are 1, 2, 3, 5 terms and one derivative, we now share the derivative with all. We now share the derivative with all, and now we are in a position to answer. Now we will actually find out the answer of each of these. Now the first term is d by dx of x raised to 7. So what we do here, there is a number attached. So we don't focus on the number, we focus on this x raised to 7 part. We focus on this x raised to 7 part. So our answer will turn out to be this 5 over here will survive as it is, and the answer will be derivative of x raised to 7 is 7 x raised to 7 minus 1, which is 6. 7 minus 1. Similarly, we do the same thing here. We see a number attached with x, so we remove the number out and we focus on the x part. So this will become 7. The x has the whatever number on top is there is 5 upon 3. So this will be 5 upon 3 multiplied by x raised to 5 upon 3 minus 1. We do the same thing here. We have only x here, there's no number, so we directly solve it. This is nothing but 2 x raised to 2 minus 1. Same thing we do here. We have no number attached, so this is just the x with number on top. So therefore what we do is we now bring the number out and we put x with 1 upon 3 minus 1. Similarly, do we do with the other x raised to half which is present over here. We put half x raised to half minus 1. So this will turn out to be 5 7 35 x raised to 6. 7 into 5 upon 3 is what? 35 upon 3. 7 5 is 35. And this will turn out to be x raised to, now I'll do 5 upon 3 minus 1. I do cross multiplication. I do cross multiplication. And this will turn out to be 5 upon 3 minus 3 upon 3, which is 2 upon 3. Similarly, I get here 2 minus 1, so it is x1. I do 1 upon 3. Now I do 1 upon 3 minus 1. To solve this, I do this. So I do 1 upon 3 minus, I'll get 3 upon 3. I'll get this as minus 2 by 3. So x is to minus 2 by 3. Again, when I do half minus 1 using fraction addition, I make the denominator common. Then I get 5 minus 1 upon 2. This is minus 1 upon 2. So I get x is to minus half as my final answer. So the trick that is to be remembered in this problem is whenever there is any root, this has to get replaced by 1 by 3. Whenever there is any cube root, it has to be replaced by 1 upon 3. Any root will get replaced by half, and any negative number when you bring on any 1 upon x raised to number when you bring on top, it becomes x raised to negative of that number. This is the trick. Cube roots get replaced by 1 upon 3 square root with half, and 1 upon x raised to any number will become x raised to minus the number. We move to the next problem. Okay. So our next problem is y is equal to e raised to x 7 raised to x log of x raised to 9 plus 13. Again, our goal is to bring each of these into standard form. We have 5 standard form: k, x raised to number, e raised to x, k raised to x, log x. Now, if you look at the first term, it is already in standard form. E raised to x is already in standard form. It belongs here. This 7 raised to x is already in standard form. It belongs here, k raised to x. This 13 is in standard form. But this log of x raised to 9 is not in standard form. So see how we bring this to standard form. We write this as e raised to x, 7 raised to x. This log of x raised to 9, this number, whenever you see a number on top of log, whenever you see any number on top of log, break that number down and you write it as log x plus 13. So whenever you see any number on top of log, bring that number out and you write log x. So your dy by dx will become, now since all of them are in standard form, we can perform a normal work derivatives. Now e raised to x plus 7 raised to x plus 9 log x plus 13. Now I share the derivative. This will become d by dx of e raised to x. This will become d by dx of 7 raised to x. This will become d by dx of 9 log x plus d by dx of 13. Now the answer of the derivative of e raised to x is e raised to x. Derivative of 7 raised to x, it falls under this k raised to x category. This is same as 7 raised to x log 7. Now this is a number attached with log. So we just remove the number and we give the answer for derivative of log x. And this answer is 1 upon x and derivative of a number 0. Now this is a number which does not have any x part, which is why its answer is 0. If this number was like this, something in x was attached to it, the answer would not have been 0. So any number without x would give the answer 0. So this with this the problem is solved. The trick to remember in this problem is whenever you see any number on top of log, that number comes down and you write log x. And one more trick, derivative of a number on its own is 0, but whenever there is a number attached with log x, you remove the number out and you focus on the x part. Now we next move to the next problem. Next problem is y is x square plus 2 into x minus 1. Now observe that in this problem there are two things which are multiplied. So in this case there is a new technique to find the derivatives called as the product rule. There is a new technique to find this derivative and this technique is called as the product rule. So what we do here is to find dy by dx, we replace this y by x square plus 2 x minus 5. Now what do we do is what? Since there are two things which are multiplied, we first find the derivative of the first thing only and we keep the second thing waiting. So this is not at all touch. This part is not at all touch. Okay. Now what do? We keep the first one waiting and then we find the derivative of the second one. So the technique is simple. When two things are multiplied, find derivative of first, keep the second waiting. Next what you do, you keep the first waiting and then you find the derivative of second. Now this derivative we'll find it by taking it out because it's slightly complex. So derivative of x square plus 2. Since there are two things and one derivative, we share the derivative inside 2. Now derivative of x raised to number is nothing but 2x 2 minus 1 which is 1. And derivative of 2 on its own without any x is 0. So this answer is 2x. This part x minus 5 is not touched, it is kept as it is. Similarly over here, the first part is not touched. Now we focus on derivative of x minus 1. So this part we take it out and we say derivative of x minus 5. This will turn out to be d by dx of x minus d by dx of 5. The derivative of x is nothing but 1. Whenever there is nothing on top of x, it is understood that it is 1. So it's 1 x raised to 1 minus 1, and derivative of number on its own is 0. Now x raised to 1 minus 1 is x raised to 0, and x raised to 0 could be replaced by 1. So this overall answer of this derivative is 1. Okay, so this problem is also solved. We now move another problem. We now solve another problem based on multiplication law. The problem is y is equal to log x into x cube minus 4x square. So to find derivative, since two things are multiplied as expected, here also if you see the log x is getting multiplied to a bigger bracket. So what do we do is we first solve the derivative to log x because it's coming first, and we keep this thing waiting. Now what you do, you keep log x waiting and solve the derivative to the second. Okay. Now derivative of log x was found to be 1 by x, and this is kept as it is. Now derivative of log x is the standard one. Now log x is kept as it is. Now we take this and solve it separately to get this answer. So we take this here. Okay, we'll take this here. So derivative of x cube minus 4x square. This will be derivative of x cube minus derivative of 4x square. Derivative of x cube is found to be 3x square. Whenever there is a number attached, we remove that number and we focus on derivative of x square. This is nothing but 2x, 2 minus 1. So this is 3x square minus 8x, 1. So this answer, we replace it here. This part over here, we put it here. And this answer will get 3x square minus 8x, 1. So we now move to the next problem to be solved. The next problem which we solve is given by y is 5 raised to x minus 1 upon x plus 1. So these are, now here in this case there are two things but both are as fractions. In this case there are two things but both are as fraction. So in this case we again find out the derivative but with a different technique. 5x minus 1 upon x plus 1. So see the way we find out the derivative. Since the numerator, this is the numerator and this is the denominator. So what do we do is we find out the derivative of the numerator only and we keep the other part waiting. Then now we put a minus sign. Earlier in multiplication, when two things were multiplied, we used to put a plus sign. Now we put a minus sign. We keep the first one waiting and we find out the derivative of the second one. The one more change that we happens is we divide it by the denominator square. So the technique is simple. It is the same idea which we use in multiplication. We serve the derivative to first, keep the other waiting, keep the first one waiting, serve the derivative to second. The only change is the middle sign has been replaced by minus and down there is the denominator square. Now what we do is we find out the derivative of this part. So d by dx of 5 raised to x minus 1. I share the derivative inside because there are two things. Derivative of 1. Now derivative of 5 raised to x is 5 raised to x log 5 and derivative of number on its own is 0. So the answer is 5 raised to x log 5. So what will happen? This will become 5 raised to x log 5 and this is x plus 1 minus this will become 5 raised to x minus 1. This then what will happen is derivative of this x plus 1 I find. So I take this derivative inside x and I find derivative of 1. The derivative of x1, whenever there's no number, it's understood that it's x1. So the number will be 1, x into 1 minus 1. And this answer is 0. So this will turn out to be 1, x0, and x0 is 1. So this is 1 into 1. The final answer is 1. Remember, x0 is 1. So this will turn out to be 1, and we divide it by x plus 1 the whole square. This is the answer. We solve one more problem under this multiplication rule. Under, under this division rule, the problem is y is e raised to x upon 1 plus x square. So even here the derivative will become what? Since there are two things, we serve the derivative to first keep the other weighting minus, now it's minus, keep this weighting, serve the derivative to the second, and then you divide it by 1 plus x square the whole square. Derivative of e raised to x is e raised to x into 1 plus x square. E raised to x, we take this inside. So d by dx of 1 plus x square will become d by dx of 1 plus d by dx of x square. D by dx of 1 is 0. D by dx of x square will be 2 x raised to 1. So this answer is nothing but 2x 1 upon 1 plus x square the whole square. Now we solve another problem. The problem is y is 5 raised to x plus x square plus 1 raised to 3. In this case, since it is a complicated expression, 5 raised to x plus x square plus 1, it's a complicated expression. We use a slightly different technique. Here, we only replace the bracket part which we see by u. So we say let u be 5 raised to x plus x square plus 1. And therefore, we are left with y is u raised to 3. Now, so whenever we see any bracket part raised to 3 and anything complicated, we replace the bracket part by u. So your dy by dx will become dy by du into du by dx. This formula has to be multiplied by hearted. Dy by dx is dy by du into du by dx. This is a formula which one has to by heart to solve such problems. So now we find dy by du, that is this first part. We find the first part over here. So now dy by du will become d by du of y is u raised to 3. So this answer will be, it will be 3 u raised to 3 minus 1, which is 3 u raised to 2. Now this is like similar problem which we did earlier, but earlier both of them were x. Now only thing, instead of x there is u. But no problem, even our answer will contain u. So this answer is 3u square. Next what we do is we find du by dx. D by dx of u is this big part, 5 raised to x plus x square plus 1. Now we share the derivative. Since there are three things, it will become 5 raised to x plus derivative of x square plus derivative of 1. Derivative of 5 raised to x is 5 raised to x log 5. Derivative of x square is 2x1 and derivative of a number is 0. So the answer is 5 raised to x log 5 plus 2x1. So we replace the du by dx part as 5 raised to x log 5 plus 2x. Now we do something called garnishing, in which we replace this u by whatever it was original. So we replace this by 5 raised to x plus x square plus 1 the whole square into 5 raised to x log 5 plus 2x. This is our final answer. We now solve one more problem. Problem is y is log of root of x square plus x plus 1. Now as soon as we see anything root, what do we do is we raise replace that root by half. That is a natural tendency. Any root gets replaced by half, any cube root gets replaced by 1 by 3. Now what we do, whenever we see a number on top of log, we write that number down and we write log of x square plus x plus 1. Now since this is very complicated, we replace this complicated part by u. Let u be x square plus x plus 1. So we get y is equal to half log u. And now we write down a formula. The formula is dy by dx is dy by du into du by dx. Now our goal is to find this dy by du into du by dx. Now your dy by du, if you replace, if you see, our y now has become half log u. So this is half log u. And whenever there is any number attached to x part, what do we do? X or u part, we remove the number out and we focus on log u. Now derivative with respect to x of log x is 1 by x. But here instead of log x there is u, so the answer will also contain u. So the answer will be 1 upon u. So over here what will come is half into 1 upon u. Now we have to find du by dx. So we have to find du by dx. Our u is nothing but x square plus x plus 1 over here. X square plus x plus 1. Now again we share the derivative. It becomes x square plus d by dx of x plus d by dx of 1. Now this answer will become 2x, 2 minus 1 which is 1. This will become 1, the power is 1, x raised to 1 minus 1. This answer is 0. So this is 2x1 plus 1 x raised to 0, and anything x raised to 0 is always 1. So this is 2x1 plus 1. So this answer will come out to be 2x1 plus 1. Now we do the garnishing, that is we replace this u by 1 upon x square plus x plus 1, and this turns out to be our final answer. Similarly, in this problem, the next problem, root of 5 e raised to x minus 1, we, as soon as we see root, we replace this by half. Now what do we do is, there is no log to bring this half down. So what do we do? This bracket part we replace by u, and we are left with what? Y is u raised to half. Then we use the formula dy by dx, which is dy by du into du by dx. We write down, we do all both these steps and we insert their answers. With this, we come to end of derivatives.